Hello everyone, my name is Bintang Arigo, and in this video we'll talk about file system management and disk scheduling. So first of all, I'll talk about file system management. The file system manages the relationship between the logical space as the user sees files, directories, links with the corresponding structure and physical location of real objects in secondary memory. The minimum work unit of the file system is the block, where it is what the memory and file system objects are divided into. The file system management uses two main techniques, which are the first one is linked allocation with file allocation table, abbreviated as FAT, and the second one is indexed allocation with 3 levels of indirection. So the first one, linked allocation with file allocation table, is the system maintains a table with as many entries as the block system have. For each object, only a reference to its block is kept, and each block has a reference to the next block in the table. So a FAT table size equals the disk size over the block size, and the blocks required for each file is equivalent to the file size over the block size. So moving on to indexed allocation with 3 levels of indirection, which is the second main technique. This technique is based on a structure known as inode. Each of the objects are associated with an inode, and the structure of an inode generally consists of the information fields, one pointer to one indirect block, one pointer to one double indirect block, one pointer to one triple indirect block. To create a new file, the inode data blocks are first used, then the single indirect, and then the double and triple to fill the information required accordingly to the file size. So here I have a table. The following table shows how to calculate the blocks needed to create a file. So as you can see, one inode contains 12 blocks. So for example, if there's 13 blocks, then the 13th block will go to the first indirection, and then if it doesn't fit there, it'll go to the second indirection, and so on. And now moving on to disk scheduling. Disks are generally organized into sectors that are grouped into tracks. These tracks are on one side or a surface on a platter, and each disk can have several platters. So each disk can have multiple amount of platters, and these set of tracks that are in the same head position are called cylinders. The platters rotate constantly, and each one head just above that reads and writes sectors. Heads move perpendicular to the tracks. Disk sectors are also referenced sequentially. Now moving on to disk scheduling, the scheduling policies in particular. So in disk scheduling, there are multiple scheduling policies that are available, mentioned below, which are 1 FIFO, second LIFO, third STF, fourth scan, fifth CScan, sixth look, and last but not least, seventh CLOOK. So the first one we have FIFO, which is first in, first out. It is a quite simple scheduling policy, and it serves requests in strict order of the arrival, and the head is always moving to look for the next request, no matter wherever it is. And the second one is LIFO, which is last in first out, and this serves requests in the reverse order of arrival. So it's basically the opposite of FIFO, which serves the first order of arrival. And the latest requests are generally served immediately in LIFO, and this generally may cause starvation. So moving on to STF, which is shortest first time, or shortest time first. This serves the closest request to head position first and minimizes the head movement, and it also may cause starvation, just like the one before, which was LIFO. And the next one is scan, which is also known as elevator. So for scan, the head moves from the outermost cylinder to the innermost, but when it reaches the end, it changes direction and returns to the beginning and continues the cycle. So it'll generally keep repeating that. And the handle requests when they handle requests when they turn up during its movement. And moving on to C-scan, which stands for circular scan. This scheduling policy is similar to scan, except when it reaches the inner cylinder at the end, it moves directly to the beginning and starts over. So this one handle requests in the same direction, and this scheduling policy, C-scan, improves scan's drawbacks, which goes over tracks that have just been seen when it changes direction. And the next one is look. This is a variation that improves scan scheduling, but the difference is that it goes up to the last request and not until the last cylinder. And at detection of no forward request, it also changes direction. So moving on to C-look, which is circular look. This includes both look and C-scan improvements, so the two ones mentioned before, look and C-scan. And this only goes up to the scheduling policy only goes up to the last request, and also when it reaches the outer, moves to the first one and starts again. And this serves requests in the same direction, just like C-scan. And that's pretty much it for file system management and disk scheduling. So I hope you enjoyed, and I'll see you on the next one.